off point. But before I dive into that, I wanted to introduce my coworker, Matt Hagan. He's also one of the developer relations engineers, and he was going to give a fresh take on Reach, what it does, all in his own words. So Matt, would you like to introduce yourself?
Sure, be glad to. My name is Matt Hagan. I'm new to Reach maybe a month ago or so, but I've been doing software development and training and technical writing to some degree for more than a few years. Let's put it that way. So I'm glad to kick it off. And what I'm going to do today is just spend a few minutes talking about how to explore Reach, since I'm doing that now. So let me share my screen and just talk a little bit about how to kind of get into Reach, how to begin to understand how to work with it. Share screen. And let me know when you can, well, can everybody see that? Maybe BB or somebody just say yes.
Yes.
Okay, great. Okay, thanks a lot. What I'm going to do is explore how to explore Reach. And so I'm going to look at installation and initialization quickly and maybe add some things that perhaps you haven't thought of yet. And then I'm going to look at the at standard lib, and especially how to start looking at standard lib. As part of the first part, install and initialize, I'm going to talk about what happens when you do Reach run. And actually before that, Reach update, just sort of what happens in the background so you have an idea of the environment that you're setting up. So let's get started with that first. Let's see how this is going to work. Okay, whoa. Okay, so looking at install and initialize, since you've done some tutorials already, this is probably no big deal for you. So you know that you need make and Docker compose. But this is where I want to start talking a little bit here. So I'm going to go over to shell here, and I am in my home directory. And so I'm going to make a Reach directory and go into that. I've got no Reach here right now. And I am going to, let me do the curl first so I can see. Oh yeah. Okay, so I'm going to grab this. This is old hat for you, so bear with me for just a second, and then I think some things I show you may be of interest. So give me just a moment here. Okay, so I'm going to go ahead and get Reach. Of course, I have it already basically, so now I have Reach, and I'm going to change mode plus executable, so now I can execute that. Okay, there you go. The first thing I think that you'd want to do is put this in your shell. So I'm just curious, have you done that already? It's nice to have it so then you can run it from anywhere. I imagine maybe you have already. So let's look at this, and just to show you, I would suggest you do this. Then you can run it from any terminal. You can also set this path inside the VS Code Reach IDE extension, which I'm going to show you real quickly. You can set it in there as well. So this makes things convenient for you. Next thing I'm going to do is talk about Reach update and kind of what happens. So let's run that first. If I run Reach update, I'm pretty much updated already. So it's just going through each of the Docker images and making sure that I've got the latest one. So point number one is when you run Reach update, you're just pulling down 6 or so Docker images that are for Reach. And I have a quick slide to sort of show you how to think about those. So we just ran Reach update, and you've got Docker installed. And so you got 6 or so images: Reach, Runner, RPC Server, React Runner, Ethereum, and Algorand DevNets. So actually the first thing that I didn't know when I first started developing with Reach is that there's a nice local DevNet right on my machine that I can practice with. So there is. So what are these images? Briefly, The reach image, that's where the compiler is. So that's going to run or convert index.rsh. This is the reach file into, by default, into index.main.mjs. MJS, of course, that's a JavaScript file, and that M is modular or modern. So this is just like EMCA script 2015 on, all that additional stuff that I had to learn a couple of years ago. And then you've got the runner image, and this is where you Reach will run your command line app, the app that I'm going to run in just a second. It has a Node.js project in it. And then you've got the RPC server that also contains a Node.js project, and that is for remote procedure calls into the backend JavaScript from a kind of a non-JavaScript front end. Then we've got React Runner in case you're going to run React app, which you do if you do tutorial 9. And then you've got the two devnets, Ethereum and Algorand devnets. This is where they get run. So this is the foundation that you're working with after you run Reach Update. Okay. All right. Let's see. A second here. Okay, the next thing we're going to do is we're going to go back to here. I'm going to go into our Reach directory. So this is where Reach lives. If I run Reach from anywhere, because of my path, I'm finding it here. So no matter where I put a Reach project, it will find it here. I'm now going to make a directory called test and go in there. So here I am in test, and I'm going to make myself a nice new kind of a template project, a Reach template project. So I'll do that with Reach init. Gives me two simple files, the two files that you're familiar with from all the tutorials, the front-end file.mjs and the basically the Reach file that will be compiled into the backend file, and the sort of the byte code for the consensus networks, and that's my .rsh file. Okay, so from here, I'm going to jump into VS Code and open that up. So I'm going to go into Reach Test and open that up, and we'll take a look right here. Okay, so I've got my front-end code here and my Reach code here. I'll open up a terminal here. I'm here already, good. And then I'm going to run one and then the other. So I'll run one for Ethereum. You can run one for Algorand as well. Go to either one of those two images. And then I'm gonna, after I run it, I'm gonna walk through what happened in a kind of diagrammatic way. So let me run one first. Actually, I can just run Reach run this. And it will just say, hello, Alice and Bob. And then let's walk through what just happened there. Okay. I hope you're all still with me. I can't see you very well. Let's take a look here. Yep, okay. Great. All right, so this is what we're working with right now. Index.mjs, this is a JavaScript file. That's wrong. You can tell the ink is definitely wet still on this. And here's my platform, basically my Docker images that I'm going to be working with. So let's start from here. I run Reach run, what just happened? Okay, so first of all, I'm pointing out that we've got a JavaScript file and we've got a Reach file. This .mjs, for many of you, probably this is perhaps old hat. Maybe you started working with JavaScript. Yeah. Yes.
We have a question from Archie. Does runner interact directly with the command line, or does it launch the command line like we learned in the demos earlier?
Runner, I'm going to talk about that in a second, but I'll jump ahead here for just a minute. Runner launches the image that gets created during the reach run process. So I'll get to that right here. So runner almost acts like a template for running the image that gets created during reach run. That do you okay? I'm going to get to that in a second as well.
That work, Archie? I'm monitoring the YouTube chat here.
I'll keep going and then go ahead and do a follow-up, Archie, if you'd like, okay? All right, so I'm going to talk about this for just a minute because this tripped me up initially, and I think it may trip some people up as well as you come into Reach. Okay, so what you're going to see here is more modern JavaScript, and so some things you're going to see are like the async and await pattern. This really is all over the place. So my point here is not to describe these as much as just to say that you're going to see this new, more modern JavaScript. And so you'll want to spend some time before you approach Reach, just coming up to speed on all the different new things that the JavaScript introduced over the last few years. And this is one of them. So this one, of course, if you don't put the await here, this will return right away with a promise object, and then it will keep executing. If you put the await, it returns a promise object, and then that promise will ensure that everything else executes until it's done, and the promise then is kind of replaced with the return value. So it's kind of like being able to do synchronous work here. So anyway, you'll see things like this. You'll also see spreader things like this through the code, actually on both JavaScript and the Reach side. And so here's a quick example in case this has not been clear to you yet of what the spreader operator does. If I had an object called company and I have two properties, and then I include the spreader here, and then you run this, then company name and company address will be in place of this ... company. So this will become part of the new person object. It's a kind of a shortcut way of popping these properties in wherever you want. Now I put this here because if we look at I apologize for this. We'll change them. I probably had to change them before, but if they were there this way before as well, this should be a Reach file. Okay, so welcome to the Edit While You Talk show here. Okay, so inside this Reach file, you'll also see this spreader operator, and it works exactly the same way. So I'm pointing out that Reach is syntactically similar to JavaScript with some differences, like it's typed, for example. But once you've learned JavaScript, you'll recognize Reach code fairly well, I think. So just pointing out that that's what's happening here, and that this sort of more modern JavaScript is in play here. All right, the first thing that happens after you type reach run is that reach RSH is compiled, and it gets compiled into by default into index.main.mjs. This is a JavaScript file which includes consensus network code, which represents the sort of the distilled contract that the compiler, how would you say it, extracts really from the Reach code. And this will now run on the consensus network. Okay, so this is what compile does. So we're still within Reach run. Once that happens, then there's the verification engine clicks in and does a verify on the code. And so when you see in your command line this output right here or similar, that's what's happening is after compile, verify happens. And then just remember that we have these images sort of below us in our environment. The next thing that happens is the compiler is going to create a new image, in this case, reach app test, which is my directory, index:\latest is what it'll say. And it creates this from the runner, which is It's got Node.js and it acts kind of like a template for this. After that, see, this is Docker sync. I think sync is part of Docker now, and it's going to look at sort of liabilities that are in these images, sort of make sure they're safe. So sync runs next. And then after that, the environment runs your app. So that's basically the steps that happen inside Reach Run. Okay. Okay, now, the next thing I'd like to do, this is really the last thing I'm going to do here, is talk about how I have been exploring Reach from the client point of view. And so,
Can I interrupt? Matt,
yeah.
1 second. Leon had a question. Is
Sure.
index main MJS because index RSH is exported main? So like index main being because you exported it main. If I exported 2 in index RSH instead of main, is the compiled result index.foo.2.mjs, or is main naming enforced?
Okay, where does the naming come from for the resulting .mjs file?
To my understanding, it looks like what they're asking, but Leon, correct me if I'm wrong.
That sounds right. It is. Let's see now if I know this answer. Okay. This right here is how you can configure the compiler. And Chris, correct me if I'm wrong if you know this one, but I believe you can configure lots of things, including that in this object. And we could look that up in the documentation, but that's what that object's for, is configuring the compiler. So if I'm not mistaken, it can be done there.
I'm not sure exactly. Just have to look at the reference document to find out exactly.
I'll take a peek at that after I finish this next section as BB starts, and make sure of that. I have seen this before. I just have to remember exactly where, and I believe that's it. So give me a second.
So I believe the question though was, so when you compile out, the output is index.main.mjs.
Yes.
And the question was, does that .main actually come from the name of the function main? And if you change the name of main, would it change that?
I'm not sure. Let me check on that. Okay.
Sure. You could just test it, or whoever asked could just test it, change it, see what happens. But yeah, it would be in the reference document.
Okay. I'm going to test something else. So let's check this out first, and let me get back to that. Okay. So. Okay. All right. And then on this side, exploring this now, what I found helpful is in starting to explore the basically the standard library, is to go here and then do something like console log. And run that like this. And while we're running that, let me jump over to the documentation. And in the documentation, in reference, in the front-end support section in JavaScript, this is where this JavaScript library is described. Basically, standard lib is an object library where the main object is that stdlib, the standard lib. And then it also deals with a few other objects like account and contract specifically. And each one of these objects also has a smaller set of methods. But the standard lib has the largest set of methods. So if you look over here, it's not there, but here, this is that object, which differs very slightly depending on what the underlying consensus network is, whether it's Ethereum or Algorand. But this is what it looks like. So this is a good way to start. And then if you go down here, these are the methods that you can start to use, add, etc. So these are the methods. And then one thing that was confusing to me initially when I started poking around with this is that there's actually an embedded standard lib inside this standard lib, which is really for only internal use and may not be there in a while. So you probably don't want to use this. You can kind of ignore this. This is this. Okay, so that may be confusing to you as you first start looking around. And then lastly, the way that I have been playing around with this is I then start putting in a few functions here and kind of building out from there. And let me see where I have just put one together and I didn't want to type it again. So let me just grab this. Okay, so for example, you get your standard library here, and then I'm going to say all of them when you're using these sort of these fake accounts, the local accounts, you parse currencies. What does that mean? Well, it's the standard unit, and parse currency converts that into the atomic unit. And so this little guy here just shows that. And that's what I've been doing with all the different methods, is just calling one, calling a few of them, seeing what comes out, kind of learning that way. So let me run this. I'm running this with Ethereum right now. Okay, and so you can see that standard lib, std lib standard unit and atomic unit are down here, ETH and Wei. If I'd run this with Algorand, it would be Algo and micro algo. And then you can see the, if I've got 100 ETH, then that's how many Wei that I have. So that's the technique I've been using to kind of play around with these different methods. I will look into, let me stop sharing for a second. I will look into the two questions that I have while BB starts and make sure that I get those answers for you, okay? And that's what I got. Over to you, BB.
Awesome. Thank you so
awesome.
much for that, Matt. I like how you broke all that down. Yeah, sure. Let me just get prepped here really quickly. Okay, so I know that Jay touched on this a little bit when he was going through the tutorial, but we also have a workshop section on our website in our documentation. And these give you different scenarios where you would be able to build dApps for different reasons. And so some of them require dependencies, some of them don't. And by dependencies, I just mean they expect you to have gone through certain, either the tutorial or a previous workshop beforehand. So the first one, for example, Hashlock, not so much, but at the top, you'll see here, this expects you to have completed the Hashlock one. And this one would have expected you to complete the tutorial. So I thought that we would start with one that's pretty simple. It's probably like a fifth as much effort as the tutorial. So it would be, if you wanted to compile something and get something working, I think that this would be a really good first option. And here. So even though this workshop is independent, it still assumes that you have installed Reach. So if you haven't done that yet, you can do that in our tutorial. Matt just went over that screen initially, where you're going to have to just make sure that you have Make installed, Docker desktop, and you can skip through this part right here in section 1, install and initialize, because this is just building out your tutorial directory, which if you're not doing the tutorial for this, you don't need it. But you would just run the same commands that Matt just did with the curl command, and then just confirm it worked by running these other commands right here. And it's worth mentioning that if you are a Windows user, that you should go through a couple extra steps in order to get it up and running. And that's installing Windows subsystem for Linux. And something that I've been noticing some of the attendees in the hackathon getting stuck with is, so when you're installing WSL, it kind of partitions from the rest of all of like the storage space on your computer. So I just wanted to show you this quick hack to find the files that we spin up when we run Reach init. And So all you're going to do is just make sure that you're in the directory. Oh, actually, sorry, I have to show you. We have to create the directory first. So first you're going to do make dir, make directory, and then run this line. And then this is going to spit you out into the FOMO workshop directory. And then you're going to confirm that it's installed, and then reach init right here is going to spin up the index.rsh and the index.mjs files. I've already done that. So as you can see, I have my directory right here. So what I'm going to do to just pull up the location of this in my actual file explorer is run this command, and it's automatically going to pop it up. So if you're old school like me, you just get some satisfaction out of a drag and drop. So I'm just going to open these two files in my VS Code, not to be confused with regular Visual Studio. And they are all here. Okay, so the first, this first workshop is an auction, and it's a really simple transaction. A funder sets a ticket price and a deadline, and every time a buyer gets a ticket, the deadline gets reset. And so here in this section, we want to think about the problem and reason our way through the script. So here are some prompts. You can use these pretty much for any dApp that you're going to create. Who is involved in this application? What information do they know at the start? What information are they going to discover and use in the program? And what funds change ownership during the application and how? And I think it's a really good idea. And when I first started going through these, I would try my hand at going through some of the logic, and I was horribly off the first time. And then I started to get into the rhythm of it. And so this is what Reach came up with. Of course, this is written by, I think, by Chris, one of our other developers. So these are some of the things to consider. The program involves two parties, the funder and the buyers. The funder is going to deploy the auction, and the buyer is going to purchase the tickets. And here we know the funder knows the deadline and the ticket price at the beginning of the application, and the buyers don't know anything of the deadline or ticket price when the application begins. That's half the fun. And the funder does not learn anything during the program execution. The buyers learn of the ticket price and deadline during the program execution. Of course, that's the whole point. And buyers continually are adding funds to the balance during execution until one buyer wins and takes home the whole balance. And then we move into the second section. So now that we kind of have an idea of the data types that we're going to be working with, we want to make sure that we can properly assign them. So this section is actually broken up into two parts. So the first things to consider are what data types are going to represent the deadline set by the funder. And then another data type for the ticket price, also set by the funder. And then we also want to know what data type is going to represent the buyer's decision to actually buy a ticket. And then the second part of this, and then Jay went over this quite a bit in the tutorial, but just the participant interact interface for both the buyer and the funder. And then I just wanted to real quick talk about the interact object really quick. So this references anytime that a participant starts a program with any knowledge. So if you'll remember, when we were going back and establishing what is known over here, we know that the funder knows about the deadline and the ticket price at the start of the application. So we would use that. All right, so to go back over here and look at the data types that we are going to use, and according to what's available in our standard library, the deadline will be represented with our uint, which is our unsigned integer, and it signifies changes in block numbers. The ticket price will also be a uint, and this decision to buy will just be this function right here based off of a bool. So if we go through it, this is what it looks like. This would be the common interface. This shows the address of the winner. And then for this one, so we have the funder interface, and we're passing through the common interface just right here. And this is the deadline. And you can see here the ticket price and the deadline are both uints. and then the buyer interface over here. So this section really touches on the communication and the transfer between participants. And that's really important for building dApps. And if you remember with the tutorial, if we were to go back and forth with that communication logic, it would be all of this. Alice publishes the wager and she pays it. Bob accepts a wager and pays it, and so on and so forth. And it gets really granular, but thus is programming. In our case, because we're doing a pretty brief auction, it's just this. So all we have to really think about in this case is the funder that publishes the ticket price and the deadline. And then while the deadline has yet to be reached, so the app has not concluded yet, it'll allow a buyer to purchase a ticket and it'll keep track of the last buyer. And then in the very end, it'll transfer the balance to the last person who bought a ticket. So we're going to get into writing the body of this. And we're going to start thinking about the front end. Actually, hold on one second. I wanted to show you guys something else. Okay, yeah, so before we get into that, I just kind of wanted to show you the parallel reduce, or just explain what it is. So here you can just kind of see what it looks like when it's embedded. And so basically it ensures that everything adds up when the program ends. So the balance just has to be equal to the number of tickets sold multiplied by the ticket price. And then you can see that in action right here. So we're gonna start it off. The funder publishes the ticket price and deadline, pretty straightforward. And then here you see the parallel reduce, and this is while the deadline has yet to be reached. So all this is going on, and then it'll allow somebody to buy a ticket. And then this keeps track of the last buyer. And then of course you have to have a timeout. That's, it's part of achieving consensus. And then whoever wins, it gets transferred. So you can see as we isolated the logic verbatim, now we're just coding it out. And as far as the insertions, like there's really like not a lot going on here. The only real interesting thing here is the parallel reduce invariant that we just went over in this script. And also what matters is a token linearity property, which just says that any tokens that are transferred into the app when it starts also need to leave by the time that the app is done. And so we're starting to now think about the front end here in this section. And anytime you see the interact object, that's how you know. And so this script is just a summary of what we did up here when we were thinking about the interfaces and everything that we just did over here. And you can see it all come together. And then now that we're thinking about the deployment decisions, this is entirely front end. So we just wrote this all in JavaScript, but Reach also supports Go and Python. So you basically could use whatever language you're comfortable with in this case. And so I already had my scripts ready to go, and I just kind of wanted to show you guys the end results. Okay, great. And as you can see here, we have a winner. So that concludes the auction. Super straightforward and super brief. So if you guys have any questions, and you get stuck at any point, well, you're welcome to join the Discord channel, and one of us will be happy to help you. But I definitely recommend, if you're interested in venturing off and doing different workshops, I would definitely consider starting with this one. So yeah, that's all I got.
You mind if I jump in and kind of point out a couple key points of this actual application?
No, not at all. Would you like to share your screen?
I just let you. It's very, very few.
Sure.
So like the really cool things, kind of really like what is the what makes the FOMO workshop and a special one to go right after the rock, paper, scissors is that rock, paper, scissors just has Alice and Bob, a single participant for each one. And then, but that's not always the case. Like you sometimes with a auction where you might have multiple bidders, or where you know, you have a dynamic number of users, and that's where we have the participant class, and that's what the FOMO 3D shows, and that's where the parallel reduce comes in, because the parallel reduce is really just a loop, but it's a loop that reduces the number of participants down to a single or a single participant. So that's one of the reasons we kind of push you to the workshop, the FOMO workshop. Yeah, so that's one of the special things about this workshop.
Thank you, Chris. Great. Is there anything that anybody else would like to add? All right. Well, that concludes our Sunday session. If there's anything else?
I should jump in real quick, BB. I'm looking into that main question that we had. I do know that you can't go into the .rsh file and just change main to foo and then compile. It's expecting main. But I did read somewhere that it can be different. So I've reached out to one of our engineers, and what I'll do is I can just post that, I think, on Discord, or in some way get that information out. But it's in the documentation somewhere. So far, that's what I've got.
This is Leon. I asked the question. That's not really asked. That was just more of like, I wonder what happens kind of question. So it's okay. It's okay. I mean, I'll follow the channel to see if there's an answer. But
okay, good. I see what you're saying. Yep. Okay.
One thing related to this, just keep an eye on, that's not built yet, but one of our engineers, Matt Odess, is in the process of building a packaging system for different reach files. So you can kind of think of like NPM, but for reach. So that's coming hopefully soon.
I do have a question about how the implementing the front end. So the reach backend just specifies an interface of like what type of variable to input, and I'm not sure if it had an output as the definition, but it's the front end's job to really implement that. And when I publish my app, anyone could theoretically make an implementation of my app, correct? Not just me. Like I can make a React front end, but someone can say, okay, I want to make a Go front end or Python front end, but then implement it in a wrong way that will abuse my backend. Is there like, or am I just not understanding how dApps work?
I'm not sure I follow. Chris, do you have an insight on that?
So what it is that because of the endpoint projection and how we actually output the entire thing, there's automatic catches put in on the actual contract side that's actually impossible to put in data that would break your app. You could try, but I mean, once you actually compile your application, take a look at the smart contract that is output. You'll see many requires in there that would prevent any type of data being pushed through that would break it. So yeah, no, you wouldn't be able. No, somebody else would not be able to build a front end that would end up breaking your application. They could build a new front end if you pass them the output of the client, the client backend, and it would work similar to how yours does. So yeah, there's safety built in so that wouldn't happen.
Oh, okay. I understand your question now. Okay, got it. Was that helpful, Leon?
Yeah, so I guess then to put a concrete example, so in the tutorial we have randomness involved.
Sure.
And if in my front end, I implemented a randomness, but let's say my app, if you don't provide randomness, it kind of gives you unfair advantage to the person who doesn't have randomness involved. Or like we talked about different implementation and where some random functions might be better. So developers might choose to do something that's other than the standard lib.
Yeah, so I think randomness is actually a great example. Phoebe, do you want to answer this one? I don't want to step on this at all.
Oh no, go ahead.
Okay. Sorry about that. So this is why like randomness is actually very difficult to have in the blockchain world because of the transparency and everything of that sort, and how you're relying on the client to provide the randomness. So the way to do randomness on the blockchain is, say, if you have Alice and Bob participate, that both Alice and Bob submit their random number. That way, if only one of them submitted a random number, then the other one actually submitted a standard number, then there would be a way to there would still be randomness. And the way that you would actually do this is the salt and hash, like the Alice and Bob do in the tutorial, where both Alice and Bob would submit a salted and a hash randomized number, and then they would both reveal. So it would be impossible for one of them to look at the actual chain, say, oh, I see what that number is, so I'm going to submit this number to actually to get the correct number out of it. Does that make sense?
Okay, great. I think you said yes. It just cut off.
Oh, okay.
Yeah.
So yeah, so random numbers, to be very clear, random numbers in blockchain is actually very difficult. This is why a lot of protocols are looking into implementing them itself as part of the protocol. I know that Algorand is looking at this, so that you don't need to rely on the client side to submit the random number. You can actually pull a random number from the protocol. And then there's other entire protocols like the Keep network that specialize in random number generation.
Yeah, I could see how that would be a problem. Okay. All right, great. Well, if nobody has anything else, we can conclude this session. All right.
Ready.
Thank you all for your time. Enjoy the rest of your Sunday.
Thank you so much.
Bye.
Great job, baby. Great job, Matt.
Happy Mother's
Amazing
Day, Chris.
session, guys. Thank you.
Of
Chris's
course.
reaches.
Bye.
See you all on Discord. Discord,
Absolutely.
excuse me.